a root, there's a few different ones that we're going to be looking at. We might look at, or we will look at the square root. Say the square root of 4, and you know that the square root of 4 is 2. We might be looking at a cubed root. Let's say cube root of 8. The cube root of 8 is also 2. We could be looking for a fourth root. Say the fourth root of, let's go to 81. The fourth root of 81 is 3. So what they're asking here is, if we're dealing with a square root, we're saying what number when multiplied by itself will give me 4? Oh, 2. 2 times 2 is 4. Here I'm saying what number when multiplied by itself 3 times will give me 8? Oh, 2. 2 times 2 times 2 is 8. And this one, a fourth root, you know what number when multiplied by itself 4 times is going to give me 81? 3. Okay, 3 times 3 times 3 times 3 will give me 81. And we're going to be looking at those, and we're going to be doing fifth roots also. So not just those, but we're going to keep on going. When you're looking at a radical sign, let's put that out here, radical. You have this, and you need to know the parts. So the B underneath there, this B, is called the radicand. The N is called the index. And of course, the sign here, the sign is called a radical sign. So that's what we have when we're looking at a radical. Okay, what if I have something like this? Here's an example for you. And I'm going to go ahead and put that in orange. And in my example, I have the cube root of 125. Let's just say you don't know what the cube root of 125 is. Maybe you do, maybe you don't. It is one of the common ones. But let's just say you don't. This is what you're going to do. You're going to break that guy down. 125. I can tell 25 goes into it 5 times. Well, that doesn't help me exactly, because I need 3 things. 3 of the same thing, right? Like this one. Let's go back up here. This would look like square root 2 times 2. This would look like square root 2 times 2 times 2. So I have 3 things here, and I can pull out a 2. This one is going to look like this, 3 times 3 times 3 times 3. I have 1, 2, 3, 4. I'm looking for 4. Sorry, put in your 4, put in your 3. Looking for 4, 1, 2, 3, 4, that means I can pull out a 3. Okay, well here I only have a 25 and a 5, and I need 3 of something to be able to simplify this thing. Well, 25 is 5 times 5. So now you can see I have 5 times 5 times 5, which is going to give me, in the end, 5. So the cubed root of 125, I broke it down. I have 1, 2, 3. I can put all those together, bring it outside the radical sign, and my answer is 5. Here's an example with a negative radicand. Ooh, bad writing, that says radicand. So here's one with a negative radicand. can go back up here and highlight these in yellow. These would be our definitions. This is actually definition 2, picture definition. Okay, here is 1. I'm going to do a square root of negative 16. Okay, a square root. I don't show the 2, but it's there. The square root of negative 16. Well, what number, when multiplied by itself, is going to give me negative 16? Well, I don't know. I mean, 4 times 4 is 16, but that's not negative. I would need a negative and a positive to give me a negative. So this one is not real. Now, we do something with imaginary numbers, but this one in particular is not real. So if you have an even index, okay, if you have an even index, then no negatives. But what if I have this? What if I have a cube and I say negative 243? I'm going to go to the 5th. Sorry, I'm going to change my plan here. Go to the 5th. That should have been to the 5th. Okay, negative 243. Well, I actually can find something. My answer is going to be negative because I'm going to multiply it together 5 times. So that would give me 5 negatives multiplied together, which would be okay. I can actually get a negative radicand. So let's break this one up. I know my answer in the end is going to be negative. I'm not really going to worry about that negative sign right now. I will break it up by 3's. So once you break this thing up, what you're going to end up with is this. And I'll show you how to break them up here in just a minute. I know it's going to be negative. There's 1, 2, 3, 4, 5. I was looking for 5. 1, 2, 3, 4, 5. I can take all of those, put them together, right? 1, 2, 3, 4, 5. Put them all together in a nice little package. And when they come out, what they give me outside that radical sign is a 3. So my answer then is going to be negative 3, and that's okay. So if you have an odd index, it's okay to have a negative radicand. Alright, so there's a couple of things for you to know. Okay, what if I want to solve for a squared term? I had something like this, x squared equals 144. X squared equals 144. Well, what I'm going to do is I'm going to go ahead and take the square root of both. I'm taking a square root because this is a square, so if I take the square root of that, those cancel out, end up with x equals, and what happens here is it could be 12, but think about it for a second, because what else could it be if I'm going to square something? Well, the other thing it could be is negative 12. So what I end up with here is x equals plus or minus, that's how we usually show it, negative 12. Here's another one for you. 4z squared minus 24 equals 0. I'm going to go ahead and add 24 to both sides. What I get is 4z equals 24. Divide by 4. Oops, squared, sorry. Z squared equals 6. I'm going to take the square root of both sides to solve. And what I'm going to end up with is z is equal to plus or minus square root 6. So I am going to get that plus or minus when I'm solving for x squared. Okay, let's continue. Roots and radicals. Almost finished. Okay, roots and radicals with a variable. If I have the square root of x squared, that is going to give me x. If I have the cube root of x cubed, I'm going to end up with x. If I have the fourth root of x to the fourth, I'm going to end up with x. Okay, if these match, if your index and your power match, then you're going to get the base. Okay, if the index and power on the base match, then you get the base. Alright, you get the base. Kind of hard to tell, that is a blue pen. So you're going to get the base. That's one of the things you need to know. Okay, if they match, you get the base. Let's see, what else could we possibly need? How about one like this with a variable? What if we have the square root of x to the fourth? Well, this can look like this. Remember, I can take this and say, oh, well, it's the square root of x squared times x squared, or the square root of 1, 2, 3, 4. A couple different ways to look at it. I have a squared here, even though we don't show it. Okay, so I need 2 to bring out of the radical sign. So I have an x here, and then I need these two. Those two are going to bring me out another x, and my answer here is going to be x squared. So I have these two x's. I needed 2 to take 1 out. Another thing you can ask yourself is, how many sets of 2 are there in 4? How many sets of 2 are there in 4? Oh, there's 2 sets of 2 and 4, so I have x squared. We'll work with that quite a bit in class. Well, I think possibly we have it. Here's another example for you. Just one more, I think, and I will be finished. If I have something like that, these match, like what I was talking about up here, like this looks like this, so what I end up with is x equals 7, but think about it for a second, because I'm going to square it. I can either have 7 or I can have negative 7 for my answer there. So watch those. If it's an x squared, or x to the fourth, or x to the sixth, something that's positive, you have to think about the other possibilities. So it could be plus and minus, or it could be just minus if your index is odd. Okay. Alright, I think that's good. Everything else we will go through in class. So good luck.